Math 1314, section IC1, spring 2022, Tyler Junior College, homework 9.5/9.6, exponential and logarithmic equations, video for applications, plural, of exponential equations. Now, it would be impossible for me to cover every possible type of application for an exponential equation. So I'm just going to cover one with the assurance that the ones on your homework all pretty much act the same way. So let's take a look. Still in the homework. Here we go. Use the model A equals P times E to the RT power, or A equals P times the quantity 1 plus R over N to the NT power, where A is the future value of P dollars invested at an interest rate R compounded continuously, that's the first equation, or N times per year, that's the second equation, for T years. This is a callback to the first homework assignment in chapter 9, the homework 9.1, 9.2, where you have to use a formula to calculate a future value. Now, I'll tell you right now, the ones in your homework, I believe, only use the continuously compounded interest, as you can read in this problem. If $15,000 is invested in an account earning 7% interest compounded continuously, and that's the word that says the first formula, determine how long it will take the money to triple round to the nearest year. In other words, how long is it going to take for me to get my money? $15,000, 7% interest compounded continuously. When will it triple? Let's capture that question here. Let's get everything ready. Got to get the formatting ready. There we go. Example. How long will it take $15,000 to triple in value, comma, if invested at 7% interest compounded continuously? I think I can fit this around my big head. There we go. No, there we go. That's what I wanted. All right. Well, the word continuously here, when you're talking about compound interest, means that you will use the following formula. A equals P times E to the RT, excuse me, the R's up here, to the RT power. And we are solving for T, because we want to know how long will it take, which is in the exponent, making this an exponential equation. Let's put in all the values that we know or all the values that are implied. Our principal is $15,000. That replaces the P. The E is a constant. The R is interest rate, but we use the decimal equivalent. 7% is a decimal is 0.07. We don't know the time. That's what we're trying to find. But what's the future value, the capital A? Well, if we're tripling our money, then that means to multiply by 3. And 15,000 times 3 is 45,000. So our task is now to solve this for T. So it's just an exponential equation. We have a strategy for doing that. Move number 1 is to isolate the part with the exponent. Who has the power on it? Only the E. So our primary goal is to get this red rectangle by itself, which is currently being multiplied by 15,000. That's easy. Divide both sides by 15,000. If you don't write the dollar signs, it's okay. That will cancel the 15,000s. On the left, unsurprisingly, 45,000 divided by 15,000 is 3. That's because we were tripling. And then what's left is whatever is under the red rectangle. Well, what was under the red rectangle was that. E to the 0.007 T power. 0.07 T power. Okay. Now we've isolated the exponential part, which means now it's time to take the natural log of both sides. Let's do that on the next page. Maybe. 3 equals E to the 0.07 T. We're going to take the natural log on both sides for two reasons. Number one, the right side is base E. E plays well with natural log. Number two, and more importantly, the thing that we're solving for is up in the air. We need to use the power rule to bring it down in front, and that's what the power rule is designed to do. Well, it's not designed, it just happens to be that way. We're going to take that power and we're going to bring it down in front of the log that it is currently inside. We get the natural log of 3. We get 0.07t, and I didn't put that in parentheses because it is not a binomial, it's a single term, and therefore embedding it inside of a multiplication problem is not going to be, hold on, get this drawn a little bit better, 0.07t. Putting a multiplication problem inside of another multiplication problem does not invoke extra parentheses, but notice I have a natural log of e, and remember that if you ever see the natural log of e, remember that the natural log of e is equal to 1. So you should be happy when you see it, because now the right side is 0.07t times 1, but multiplying something by 1 doesn't change its value. Natural log of 3 equals 0.07t. Keep in mind that we're solving for t. All that remains now is to divide out the 0.07. And we get t is exactly the natural log of 3 over 0.07. Now, before we get out the calculator, I want to point out that the 3 for tripling and the interest rate 7% are perfectly intact, which means that we could adapt this problem for anything that we wanted. The number inside the natural log is the multiplier that we want on our money. Like if we only want twice our money, then the 3 would be a 2. Or if we wanted 10 times our money, then the 3 would become a 10. And the denominator is the interest rate. So if we found a lower interest rate, like 5%, it'd be 0.05, or a higher interest rate, we could replace that as well. These are nice things to think about when you're solving problems like this, because it means that you can adapt to new situations. Let's put this in a calculator. And to the nearest, these are years. Let me see what they want here. We can look together. Maybe if I can, that's not what I meant to share. Not that I'm sharing anything. Look at that. This is what I wanted to share. No, it's still not what I wanted to share. Where's the homework? There it is. Wait a minute. Oh, I know what it's doing. I know what it's doing. It's sharing a browser and it's not sharing the browser. There we go. Okay, you might not have seen what I just saw, but that's okay. Round up to the nearest year. I want to point out the wording here, round up to the nearest year. It doesn't say round to the nearest year. It says round up. So no matter what our decimal it is we're going to round up. Now I'll show you what the decimal is. $15.69446127. So if I were rounding, I would round that up anyway. But even if it were 15.01, I'd round it up. Now, why do we round it up? Well, that's easy. If you round down, then you're not going to end up with as much money as you want. The longer you leave it in there, the more you get. So if you take this time and move it down, then that 45,000 you thought you were getting is going to be less. I'd rather overshoot it than undershoot it. So that's why it said round up. So it's not a difficult problem. It's just a basic exponential equation. Yeah.